what I wanted to look at today was this GSM module. So you can get these modules that allow you to connect to the GSM network quite cheaply now. So this one is an older one that I've had for some time. So this is called the SIM900, and you can see that this is really designed to work together with an Arduino. So it's purposely been given these headers so that which way around is it? So that it can be connected to an Arduino. There we go, like that. So you can assemble it in a stack and use it together with the Arduino. So I'm not going to use the Arduino today. What I'm going to do is wire it up as simply as I can, and I'm going to connect it to the computer so that we're actually interacting with the module directly using the AT command set. Now I've got a smaller, cheaper module on order at the moment, a SIM900, and when that arrives I'll make a video on that one as well. But just to kind of show what kind of things you can do with these modules, what I wanted to do is set this up so that I can send and receive texts. So this module, to make it work, really all we need is power, and we need the serial interface on this side connected. So the receive and transmit pins need to be connected into a device. And what I planned to do was to use one of these serial to USB modules so that I can plug it into my computer here, and then I'll be able to video off the screen so you can see what I'm doing. So this module is more sophisticated than some of the cheaper ones. So you've got an SMA connector here, so you can put on one of these kind of omnidirectional whip type antennas. But you can also see on the board here there's a tiny little sort of coax type connector. I think this is called an IPEX. So you can see that you can plug an alternative antenna into that. So what you can also do is you can use one of these patch antennas. So this is like a printed circuit board that's been made with with the right dimensions to be a GSM antenna, and this comes with the IPEX connector on the end also, which allows you to plug it in on the board instead of the SMA. But I think what I'll do is I'll use the whip. Now you'll see that I've already put a SIM card in the slot there. So I ordered a pay-as-you-go SIM card from a UK company called 1P Mobile. So they allow you to send texts for 1p each, which is reasonably cheap. This module also has a battery backup, and that's because it's got a little real-time clock on board somewhere, a real-time clock chip like a DS1802 or some such. So this can actually remember the time. You can set the time, and it will remember the time and date even when it's powered off. I'm not going to use that today. I'm just going to do the simplest possible sort of SMS send and receive that I can. Right, let's just plug that IPEX connector back in again. It's sometimes a little bit fiddly. Yeah, I think that's got it. What else to say about this board? I mean, this is a rather sophisticated board compared with some of the boards that you can get. So you'll see that this also has audio interfaces. So this one actually can be made to you can use it as a phone basically. So you can plug in microphone and speaker, and you can make phone calls with it. It also has an on-off switch, and you'll see that you have to press this in order to get the board to fully activate. Actually, I already have one of these, so a very similar board to this, which is set up in the shed, and what that does, that's been running for some years, probably 5 years now, and what that does is it senses when the power has gone off in the shed, and it transmits a text to my mobile phone. So the idea there is if the power goes off, there's a freezer in the shed that has some food in. So if the power goes off, it sends a text to my mobile, so I know to take some action to go and reconnect the power again. So these are quite good modules and quite reliable, but quite expensive. I think these are around, I think I paid about 20 for these when I first started using them. Now they're down a bit cheaper, I think 12 or 13 pounds. But at the bottom end of the market, you've got things like the SIM900, and there's another thing called the M590, and those can be as cheap as £3 or £4. So we'll look at one of the cheaper ones in a later video. So in terms of connecting this up, so I've got this USB serial module here. Now, although you can get 5 volts power from this, it's not a good idea to try and run these modules off a USB interface, because the documentation for these says that you need a power supply that can provide 5 volts at 2 amps, and a USB interface, typically can't provide 2 amps. So what I'm going to do is I'm going to put 5 volts power in here from my bench power supply, so I've got 2 amps available. And then this is just going to be connected to the serial interface, to the receive and transmit. So I've got split earth cable here, so that the ground from the computer is common with the ground from the power supply, to make everything work well. So we'll start off with the ground. So I'll put the ground pin in here. We also need the 5 volts over here. So then this is going to be my power in over here, and then the serial, in tiny writing down here you can see RX and TX, so these are the receive and transmit pins for the SIM900, and so we need to match those up. So I've got red is receive, so I'll just connect that up there, and we've got brown transmit, and with any luck that should be enough. So we'll plug this into the computer and bring in the 5 volts power over here. There's got my wires slightly knotted up here, haven't I? Let's go ground here. And we connect the power supply ground and 5 volts, and you see now the LED has come on, so that's showing that there's power on. But actually you need to now press this button, I think for 1 second, and there's a status light over here that'll come on. Okay, so when this LED is flashing rapidly, it means that it's searching for a network, and when it's flashing slowly, it means it's actually joined a network. So this 2-second flash means it's now connected to the network, so it's seeing the 1P mobile network. So what we could do now is switch to the computer screen, and we should be able to connect up and actually see the interface with Putty, which is a tool for Windows that allows you to connect to serial devices. I should probably say what I'm trying to do overall, so let me show you a little diagram. What I'm going to do in terms of testing is I've got my SIM900 module over here, so this is connected to a GSM network, so in this case 1P mobile. To test, I'm going to use a cloud service called Vonage. So this is a sort of pay-as-you-go service that you can sign up to, and it allows you to send and receive texts using a cloud service. So this is going to be also connected to my computer here, and we'll be able to see messages that arrive in the Vonage account. And I'm also going to write a bit of Python so that from my computer I can send a message through the application interface, through the API. I'm going to send a message through Vonage to my GSM number, to the number of the SIM card that I've put into the SIM900 module. So let's switch to the computer screen, and so what I'm going to be doing initially is, again with a computer over here, I'm just going to connect in the serial port using a program called Putty, and we're going to interact with the SIM900. We can see, if we look in Device Manager on Windows, the USB to serial has popped up as COM3, so we're going to select COM3 as our Putty configuration. I've set the speed to 9600. In fact, this module is quite flexible, it will accept almost any speed. And when you type AT for the first time, the module can sense the speed, so that's a common feature on modems, sometimes called auto board. So it sets the bit rate automatically when it sees the AT command. But we'll select 9600 because that's a reasonable value. So if we click on open, that's just gone on the other screen. So if we type AT in here, so we get OK back, and I can type ATI, it will tell me the board information. So we see that it's a SIM900. I can also check if it's got a connection to the network. Well, I can see it has because of the slow flash here on the module, but we can also do it from the computer. So we say AT plus COPS question mark, and there you see it says 00, which means good, it means connected, and there's the name of the network there, which is 1P mobile here. We can also check the quality of the connection, so AT plus CSQ, and that gives us a quality measurement. So the first number there, 5, is the signal strength, or RSSI. So you can do a table lookup with this to find out number of dBs available in the connection, so the connection quality. And then the second number is the bit error rate, which you want to be as small as possible, and that's reading as 0. So it looks like we have a good connection to the network. So what you can also do, you can do this command cmgl, which shows any messages that have been received, and it's empty at the moment, so there's no messages received. So what we could do now is we could run our Vonage application. So let me show you what that looks like. So this is using the application programming interface from Vonage. They used to be called Nexmo, so this is why everything says Nexmo. But Nexmo, Vonage is the same thing basically. So what we're doing here is we've imported this API definition from Vonage, and we create a client using their API. So this is picking up the key and the secret from another file, because every user, every subscriber to Vonage has their own unique key and secret that they can use on their API. And so I'm going to send an SMS to this number, and this is actually the number of the 1P mobile SIM that I've got, that I've put into the SIM900 module. So destination is the SIM module. The from, you can put more or less any text you want in there, or you can put the number of the sender, and then this is the actual text. So let's just get rid of that, and I'll bring in my Python application here. So we'll run it. So we say send, and you see this is returned successful. So it says message count 1. Every message you send has a unique ID allocated to you by Vonage. There's even the price here, 0.03 is 3 euro cents, or 0.03 euros to send on Vonage. And if we look back at our SIM900 module, you'll see there's a new indication here. So this CMTI is basically saying that we've received an SMS from the GSM network, and this number here is a unique number, so that you can fetch that particular message. So the way that we fetch the message is we say 80 plus CMGR, and then we have the message number 1, and there we go. So we have an indication. So you've got the sender information there, you've got the date and time, you've got the actual text of the message here, and there's also the status according to the SIM900. So rec unread means that this is the first time that we've seen this one, and if we were to read it again, so 80 plus CMGR equals 1. So you see now it says rec read, because we've already read that. And if you had a computer connected to this AT interface, the serial interface, that's really useful, because then you can tell which messages you've already processed. And then so we could change the text and send another message. So let's comment that out. So we'll send a different text, and we'll send a different sender ID. So I'll just save that, and we can run our Python script again. And there you go. So we get the CMTI again. So that's an indication that another message has arrived from the network. And similarly, so we can do 80 plus CMGR equals 2 this time, and then we can see. So that's the sender ID and the new text of the message. So you can see that it's pretty straightforward receiving texts, and in a minute I'll write a bit of code. I'll show you a bit of code that will talk to this port and process these messages. So, but for now we'll carry on using the manual mode. So if I do AT_CMGL equals all, that lists out any messages that the module's got in memory. So we can see the 2 messages that we've just received. Now they're both marked rec red, and you can individually delete messages. So if I do CMGD equals 2 and AT plus CMGL equals all again, you can see that message 2 has now disappeared. You can also delete everything in memory, so it's AT_CMGDA equals del all, I think is the magic. That says, oh no, I spelled it wrong, sorry. AT plus CMGDA equals del all. Okay, AT plus CMGL equals all, and there you go. So we've got no messages in the module memory any longer. Another thing that we can do here is we can also send texts. So to send a text we use AT plus CMGS this time equals, and then the recipient's number. So how do I do this? Oh, there we go. Right, so this is my Nexmo stroke Vonage number. So I bought a number on Vonage a couple of days ago, and so it's allocated this mobile number, and if I send texts to this number, then they end up in my Vonage account, and I can go and look on the application on the console, and I can look up what the messages are. So the magic here is that we say AT plus CMGS with the destination number. If I press enter now, what have I done wrong here? AT plus CMGS equals enter. Yeah, so now I get a prompt, and I can put the text to the message. So I've got the caps lock on, but you can send, arbitrary text here. And if you press enter, it shows you another prompt, so you can put multiple lines if you want to, but then you terminate by doing Control Z. So if I type in Control Z and then hit enter again, and there we go. So the AT plus CMGS, that's an indication that the SMS has been successfully sent. So now I can go and pop up my Vonage I hope that's gonna fit on the screen. Yeah, so this is my Vonage number, because obviously you can have several different numbers allocated to the same account on Vonage, but I'm just looking at this one now. So if I do a search for the 19th of August, right, so this was a message that I sent earlier in the day, but this is the one that was just sent, so 11:47, and so we can see. So this is my 1P mobile number, so the SIM card number, and this is the destination number, and then you have the text, and Vonage actually charge you a very small amount, 0.006 pence, that is, or euro cents, to receive each text. So you see the SIM900 module has successfully sent a message to a different network. So that's pretty neat. Okay, I'm just going to demonstrate how how we talk to a serial port using Python. So if I run the Python interpreter here, so I'm going to use this library called Serial that I've used before in some videos, so you may have seen this before. So having imported the serial library, we can create a serial object, and in this case the port is COM3, speed is 9600, and we'll also say timeout equals 1. So timeout means that when you try and read something from the port, it won't block forever, but it will return after 1 second if nothing has been received. So now we can write to the port using the write API. So we have to send the text as a binary string, but if I say AT1V1 for example, and we need to put a carriage return at the end, otherwise the modem will ignore it, and that returns 7, so that says that we've returned we've sent 7 characters to the serial interface. So we can now poll on that port using readline to see what's happening. So we've got a carriage return line feed there. It said OK, carriage return line feed, and that's the end of the interaction. So the B quote just means an empty string has been returned because of the 1 second timeout. So if we do the command that we did earlier, so we do ATI for example, not forgetting the carriage return, so that's sent 4 bytes, and we get SIM900, so it's identifying itself as SIM900, and then finally we get the OK, so that's the complete interaction with the modem. Now you see that what happened first of all is that it echoed back the characters that we sent. So if I just send AT for example and then read back, we see our own characters coming back at us, and this isn't really a good thing to do if when you're running from a program, and programs can easily get confused by seeing their own output coming back at them. So what we typically do is we switch off echo, so we say ATE0, and now it said OK, we shouldn't get any echo back any longer. So if we say AT now and read the port, we see a carriage return line feed, we see an OK confirming the command, but we don't see our own AT that we've sent. So that's quite a useful setting to have in place. We can also do the same trick that we did earlier, where we send a text from another service. So if I say Python 3, and we'll run this script that we were running earlier for the Vonage SMS service. So if I run that script now, so that's sent a text like it did earlier. Now if we do readline on the COM port, you see we get another one of these indications, so the CMTI, that tells us that we've received an SMS. So now again, as we did earlier, we can do AT plus CMGR to read the message, and we put index 1 because that's what we got on the CMTI. And if we read the port a few times, there we go, we see the text header there and the actual message text. We should see an OK. Yeah, so we finally see an OK as well. So you see, then it's possible for the computer to to issue this command and then pick up all the lines of text that get sent to the port. Similarly, we can send an SMS, so let's do that. So we want to do CMGS, and we need to say where we're sending it to. I'll get the Nexmo number again. Not quite doing this right somehow. What's happening? No. And paste. There we are. So we have the number in quotes, and we have the carriage return again. So we send that. So we've sent 23 characters, 23 bytes. And similarly we do read line, so we see a carriage return line feed. And now we see that greater than symbol. And if you remember earlier, when we're sending the SMS, as soon as we've sent the first line, we get this prompt back to tell us to put the text in. So we'll write some text. Sorry, not directly like this. We need to put it in a string, don't we? So and we've got a carriage return there, but here we also need to put a Control Z, because Control Z is what ends the CMGS command. So in Python that's \x1a. So we got Control Z and then a carriage return. So we do a write, and then let's poll the port again, get carriage return line feed, and we get that CMGS, so a confirmation that we've successfully sent a text, and finally the OK as well. So then if we go back to the Vonage console, fill in our Vonage number, and if we do a search here, we see here's the text that we just sent, and you can see the text of the message that has just arrived in our Vonage console, and again the sender's ID and the destination ID. So that's the basic principle, and then so it's just a question of building up more Python around these serial port commands to send the text that we want, send the commands that we want, and then expect all the various bits of text that are coming back from the serial port. So that's where we'll go next, where I've written a bit more code to to write a more sort of more fully implemented SMS interface for the SIM900. Let me show you my Python script that I've written to receive an SMS. So I'll go through this in some more detail in a minute, pick out a few details for you. But let's see what it does first of all. So in the green text here is where I'm going to do the SMS send. So again, using the Nexmo API to to send out a text to my SIM900 module. And the white text here, I'm going to run the read SMS application that I've just written. So if we start it up, it's initialized the port, but it doesn't put anything on the screen at this point. But let's send out a text now. And here we go. So we've got receive SMS 1, so that's the CMTI indication that we saw earlier. And then what I've done is unpacked the various phases of the SMS receive. So this is the header here, is the thing that appears in the first line when you do the CMGR. So when you read the text back, and then this is the actual content of the text. So this is the text itself, and then the operation completed here is when the OK message is received. So if I go over that again, so if I run it again, so as you see now we've got SMS number 2. So this is the number that you get on the CMTI indication. So to make this as simple as possible, all this is really doing is the receive part. I'm not doing the delete message in here, so the CMGD, although when you first start it up, so if we go down here, so this is initializing the COM port. So we've got COM3 speed 9600, and then I do this create an object of type SMS, which is this code up here. So the init here is the constructor. So this is basically saving that that serial object for later use, and then we do some initialization of the port. So I'm switching the echo off here, and also running that CMGDA del all, so that removes any messages that are stored in the module when you first kick it off. And there's two other methods in this particular class. So the receive is just reading a line back from the COM port, and then the write line is writing some text to the COM port. So this is what I use to send the AT commands, and this is what I use to receive any text that's coming back from the module. So a lot of the heart of this application is in this section here, where I pass in the line of text that comes back from the module, and I'm using regex here to match various bits of text to extract the goodness that I'm interested in. So the CMTI message here, I'm using this \D to pull out the number, so the SMS number, which I'll need later for the CMGR command. And then similarly, when you get a CMGR indication, I'm using regex to find all the parts of the message that are in double quotes here. And then you see various other messages that I'm intercepting. So when the module says OK, or when it says error, I'm turning that into a parsed version that's easier for the main application to deal with. So the main part of the application is just to go into this permanent loop, so while true. So it's just receiving a line of text from the module, and then assuming it's not a blank line, it then calls that message type routine to find out what type of message it is, and any parameters that came with it. And then based on the type of message, it does a bit of processing. So here we've got the if it's the CMTI, we get this RX SMS indication, and if if it's indication.txt, that's the CMGR response. And yeah, I should say, so when we get the CMTI message, you see one of the things it does here is it uses WriteLine to send the CMGR, and it's filled in the SMS number, so the 1 or 2 that we saw in the test just now. So this is sending some text back to the module, and that in turn will make another line of text appear here, the indication.txt, which we can then use to pull the header information out of the text. And then finally, if so when we do the CMGR, we set this text owing, because we don't know what that line of text will look like, so there's no way to have a sort of to be able to match it to a particular message type. But what I'm saying here is that if we've done CMGR, then we say text owing is true, which means that this next section will fire when we read the next line. So we've got indication unknown because we don't know what type of message that is, but text is owing, and therefore it knows that this is the actual guts of the message. This is the text itself. So this is the line that you see on the screen when the code runs. So you've got SMS followed by the header information, which we found earlier, and then the message text. So that's fairly straightforward. Obviously you could add more cases here. So having got the OK, you could do another SMS write line, and you could issue a CMGD to delete that text from the module memory. And I'll probably add the send text and delete text to this code when I get a bit more time to work on it. So I'm going to put this script and the other the Vonage send text script, I'm going to put those on my GitHub site if you want to download them and experiment with them, and and improve them if you like, and enjoy experimenting with the SMS module if you have one. And so this is once again, if you look, this is the final indication with the contents of the text. So that this is the header information that we recovered with regex, and this is the actual text itself. And if we if we have a look at the send SMS text, the right name in there, you can see that I changed the text message that we were sending earlier, so it's now got my YouTube URL. So that's all I wanted to say about the SIM900. I'm probably going to repeat some of this when the SIM800 module arrives with me, because I want to do a bit more experimentation. But I hope you found that useful. There's 2 different ways here that you can send and receive texts, either using a cloud service or these very useful and really quite inexpensive GSM modules. So thanks very much for watching, and I'll see you in the next video.